Hello and welcome to R&D Math. In this section, we are going to talk about calculus of parametric curves. Now, let's say you have x equal f of t and y equals g of t, another function. Now, in this case, well, how do you, in certain case, you have to find dy by dx. Now, how do you find dy by dx? Because x and y, if you don't see the relationship, but they are expressed using t, in this case, y by t and then t by x, the chain rule. Oh, you can write this as dy over dt divided by dx over dt. So this is what you need to remember in order to differentiate it. Now let's see an example, then you'll understand. Let's say you have to, let's say you have to find the tangent line. Find the tangent line for the line, no, sorry, for the curve given by this equation, x equals secant t. So this parametric equation. Remember, when we say parametric equation, it's actually a set of equations. So tangent line at t equals pi by 4. So how do you do that? Well, actually, this is how we do this. So dy by dx, using our earlier story. So first y by t and then dx by dt. Now let me go back and show you. See, this is this part, it's coming from chain rule, this one right here. Now dy by dt, secant, when you differentiate secant squared t, and the tangent, sorry, dx, sorry, dy by dt, so tangent, derivative of tangent is secant squared, so that's why you get secant squared t divided by derivative of secant. Secant is secant tangent, so secant t tangent t, and one secant will cancel, so you get secant over tangent, so secant t over tangent t, that's dy by dx. So that is slope, right? So this one is actually slope because dy by dx. Now we have to find that dy by dx at t equals pi over 4. Yes, you don't see any t in this part, but t is hidden. It's here. So secant pi by 4 and tangent pi by 4. So secant pi by 4 is root 2, tangent pi by 4, which is 1. So the slope is root 2. And then you know the slope, right? You know the slope, that is m, and you have to find the line at that slope. So whatever the curve is, at that particular point, you have to find that line, tangent line. Now you already know the slope. What you just need is this point where it is touching and going your graph. So in order to find that, pause the video and think about it. How do you find that slope? Sorry, how do you find that point? What you need to do, plug this value here, then you get x and y that this point. So x is secant pi over 4 and tangent pi over 4y. So tangent pi over 4. So that's root 3, comma, tangent pi by 4, 1 secant pi over 4. So root 2, right? Because secant is 1 over cosine. Cosine 45 degrees is 1 over root 2. So secant is root 2. 1 over, so reciprocal. Now we are almost done because y minus 1 equals slope, which is root 2, x minus that. So you get y equals root 2x, root 2 into 2, which is 2, so negative 2, and then plus 1, you get negative 1. This is the equation. Okay. Now, what if you have to go for second derivative? The second derivative. Now, the second derivative, d squared y by dx squared. This is dy by dx again by dx, right? Or in other words, let's write y prime for this guy. It's easy to use and remember. So this is dy prime first by t and then t by x. At this point right here, we are using the chain rule, right? Now, so this guy, if you want, you can remember like y double prime divided by x prime, right? That is how you find that. Now let's see some examples. So let's say we had to find the second derivative of this parametric equation. So x equal cosine 2 cos t and y equals to sine t. And find second derivative. Let's say at t equals, remember it should be t, at t equals pi by 4. So what you need to do, first you have to find dy by dx. In order to do that, dy by dt, so dy by dt over dx by dt. Now dy by dt, 2 cos t over negative 2 sine t, right? So you get dy by dx as, let me see, well, in this case actually, so negative cotangent x, right? Cotangent t, sorry, not x. So now that is actually y prime. Now let me call it y prime so it's easy to deal with. Now d squared y by dx squared is going to be, you differentiate this, that's y double prime. So you differentiate that. So negative cotangent t, differentiate once again with respect to t, you are going to get negative cosecant squared t divided by x prime. Oh, you already found that right here. So negative 2 sine t. Now negatives will cancel. Well, here, sorry, I made a mistake. Negative cotangent. Well, cotangent, when you differentiate, it's positive. So you have now negative, when you take cosecant down, you have 1 over 2 sine cubed t. So that's the answer actually. But you have to find that at t equals pi by 4, right? So you just have to plug that value. So 2 sine cubed pi by 4. We know sine pi by 4 is root 2 over 2 or 1 over root 2. That's easy to go like this. And when you simplify, you will get negative 1 over 2 root 2 cubed on top. So root 2 squared is 2, that 2 will cancel. So negative root 2, that is the answer. Okay guys, I think that's enough for today's video and thank you.